Welcome back, everyone. My name is Mr. Cobalt, and today I'm going to be going over Avogadro's law, and I'm going to be doing a practice problem. So this is the first practice problem I'll be doing. So let's get into this. So we have a male athlete in a kinesiology study, and he has a lung volume of 6.15 liters during a deep inhalation. At this volume, his lungs contain 0.254 moles of air. During the exhalation, his lung volume decreases to 2.55 liters. How many moles of gas did the athlete exhale? Assume that temperature and pressure are constant. Okay, so where do we begin? We're going to begin by writing down all the information that is given to us. So we're told in the beginning that his lung volume is 6.15. So that's going to be V1. V1 is equal to 6.15 liters, okay, during his deep inhalation. And then we're given the mole amount of that gas. So that's going to be our N1. And that's 0.254 moles of the air. Okay, now during exhalation, his lung volume decreases to 2.55. So that's going to be our V2. So that's 2.55 liters. And they want to know how many moles of gas did the athlete exhale, right? So what we can find first is if the volume of the lungs decreases from this to this, then we can find out how many moles of the air is left in the lungs, because it's the air in the lungs that is related to the volume of the lungs. So we can find our N2, the number of moles that are still in the lungs after he exhales. So we'll find that, but then to find the moles that are exhaled from the lungs, then we'll need to subtract this amount from the original amount that was in the lungs. Okay, so let's go ahead and begin. Okay, so we're going to set up our equation. So V1 over N1 is equal to V2 over N2. So that's Avogadro's law. Now, the one thing I forgot to mention is just like temperature needs to be in Kelvin whenever you have temperature involved in these equations. So the same goes for the amount of gas. So the amount of gas needs to be in moles. If they give you the amount of gas in grams, then you're going to need to use molar mass to convert grams to moles. So they already gave us in moles, so that's fine. We don't need to convert. So we need to find N2, so we can solve our equation for N2. So I can multiply both sides by N2, and that's going to cancel out. And then I can divide both sides by V1, and that'll cancel out. Okay. And then I can multiply both sides by N1. And so multiply both sides by N1, that'll cancel out. And then now I have N1 is equal to V2 times N1, N2, that's N2 is equal to V2 times N1 over V1. So now I have my equation set up. I can just plug in the numbers. So V2 is 2.55, so 2.55 liters times N1, which is my 0.254 mole. And then I have V1, which is 6.15. So 6.15 liters. And so now to calculate the moles, all I need to do is plug the numbers into my calculator. And I'm 2.55 times 0.254 divided by 6.15 equals, and I get 0.1053. So 0.1053 moles of air. So that is the amount of air left in the lungs. They want how much air was exhaled from the lungs. So what I need to do first is I need to indicate where my last sig fig is. So I have 3 sig figs, 3 sig figs, and I have 3 sig figs. And remember, my answer can only be in the same number of sig figs as the least number, which is now 3, since they are all 3. So my last sig fig is the 5. But I'm going to use that number in my calculation for the number of moles that were exhaled. So I need to take that number, because that's the number that is left in the lungs after exhaling. This is the original amount, so I need to subtract that from this. So I have 0.254 moles minus 0.1053 moles, and that's moles of air. And then again, I'm going to calculate. So I have 0.254 minus that equals, and I get 0. So that's equal to 0.14868. 14868 moles of air exhaled. And so now what I need to do is I need to figure out how many digits I'm allowed to keep. So here I figured out that the last sig fig for this number is the 5. So when you're adding and subtracting, you're looking at decimal places. So it's the least number of decimal places that belong in your answer. So here I have 3 decimal places. And here, if I remember, the 5 is my last sig fig. So the 3 doesn't count. So it's 1, 2, 3 decimal places. So the answer is 3. So I'm going to cut off 3 decimal places. I have a 6 there. I'm going to raise that to a 9. So the answer is 0.149 moles of air exhaled. And so that is the answer to this problem. I hope this was helpful. Thanks for joining me. If you have any questions or comments, put them in the comment section. If you like this video, like it, share the video with your friends, subscribe to the channel, and ring the notification bell so you can get notified of new videos I put out. Thanks for joining me, and I'll see you next time.